All right, here's your practice quiz, ladies and gentlemen. So watch it and learn. So number one, classify triangle ABC by its sides and by its angles. So first of all, what to decide what kind of triangle it is, we're going to have to use the distance formula. So again, I'm going to use AB. And remember, I'm going to use the distance formula. So I'm going to call this one here, let's see, this one here is x1, y1, and this one here, x2, y2. So again, if I'm using the distance formula, I'm going to say that's going to be 5 minus 0 squared plus 12 minus 0 squared. All right? And when I work those out, again, you can just plug it in your calculator right now, ladies and gentlemen, and you should get 169. All right, so let's see here. I think my face is in the way. So here, I'll put it over here somewhere. Well, here, let's put it over in this corner. All right. So again, you should know that if you plugged it in, you would get the square root of 13. But now remember, I told you just kind of leave it in square root form, and then once you're done with it, then check it. Okay. So then the next one I'm going to do is I'm going to do CB. And again, I just chose which ones to do. So if I do CB, I'm going to get, and again, let's see. Well, it's not we're talking length, so I'm going to say the length of CB. And again, if I did this, I went this one here as, let's see, x1, y1, and then this one x2, y2. So in this case, again, it doesn't matter which one you choose to be x1, y1, and which one to choose x2, y2. You just have to be consistent. So on CB, I'm going to have negative 12 minus 5 quantity squared plus 5 minus 12 quantity squared. And if I work on that one there, I'm going to get the square root of 338. Okay. Now again, if you wanted to, you could solve them. But again, I'm saying it probably doesn't make sense to. And then the last one I have is CA. So when I do CA, and on that one here, that's going to be my x1, y1. This will be my x2, y2. And for the length of CA, I'm going to get the square root of negative 12 minus 0 squared plus 5 minus 0 squared. And on that one there, then I will get the square root of 169. So if we look at it, this length here is the same as this length here. The third one is not the same length, so we know that we have an isosceles triangle. All right, now to find out if we have an acute, right, or obtuse angle, we have to find the slope. So now I'm going to find the slope, and again, on one of them, what I would suggest you do, ladies and gentlemen, is look at the one you think might be a right angle. All right? So I'm thinking this one right here might be a right angle. So I'm going to go ahead and find the slope of that one there. All right? So that means I have to find the slope of both of those lines that connect there. So I'm going to go ahead and find the slope of AB. And remember, slope is y2 minus y1 over x2 minus x1. So if I'm going to find the slope of AB, that's going to be 12 minus 0 over 5 minus 0, which is 12 over 5. And again, I would leave it in fraction form for right now, ladies and gentlemen. Keep it in fraction form for right now and see what happens. So then I said, that's this one here. So then we're going to look and see if this one here. So I'm going to have to find the slope of CA. And if I take the slope of that one, I'll have y2 minus y1, which is 5 minus 0, over negative 12 minus 0, because again, I'm taking this, and on that one there, I'll get 5 over negative 12, or negative 5/12. So remember, if they are negative reciprocals, or opposite reciprocals is what your book likes to call them, then we know that we have a right angle. So we have 12/5 and 5/12. And again, remember, if I wanted to make sure those should, when I multiply them, should equal -1, which is what they do. So the second one is going to be, it is going to be a right triangle. Okay. Again, I told you I thought that was one of the hardest ones on this test. And then the second one was this one right here. So the first two problems, if you get them good, then you're okay. So the second one there is find the measure of angle WXY. So we need to find the measure of this angle here. All right. Now remember, this here is an exterior angle, and it is equal to the sum of these two. So those are the remote interior angles. That's how I remember them. I can't remember what your book calls them. I could look, but let's just say you know that 3x minus 4 is equal to x plus 70. Okay? So if that's the case now, we're going to solve for that. All right? So the exterior angle is equal to the sum of the farthest interior angles. All right? There's another word for it. So again, I'm going to take this x over. I'm going to bring it to the other side. It becomes negative, so I'm going to have 2x minus 4 is equal to 70. I'm going to take this negative 4. I'm going to move it to the other side of the parentheses. That makes this positive, so 2x is equal to 74. And now I'm going to divide by 2. And when I divide by 2, I'm going to get that x is equal to 37. All right. Now be careful. That's not your answer, ladies and gentlemen. Remember, it wants the measure of this angle right here, this exterior angle. So this exterior angle, we're going to just go ahead and take it. So the measure of angle WXY is equal to 3 times x. Well, we just said x was equal to 37. And that's going to be minus 4. We plug that into our calculator, ladies and gentlemen, we'll find out that it equals 107. All right, so it's 107. On number 3, it says, write a congruent statement for the triangles, then identify all congruent pairs, all right, of congruent corresponding parts. Excuse me. So if we look, they went P, Q, R. So they went from one that's 3 to one that is 1 to one that is 2. So you're going to want to do the same thing. So you're going to want to go from 3 to 1 to 2. Again, you could have even done the sides. I chose to do the angles. Choose whichever one you want. So we can now say that triangle PQR is equal to angle CBA triangle. And they already got it there. Don't put a triangle there. Okay? So now we can still again match everything up. So I think on this rest of it's a drag and drop. All right, so look at our Q. Which one is the same as Q? Well, that's going to be angle B. Which one is the same as R? R is 2. So that means it's going to have to be angle A. And then that would make P and C be the same. Okay, and now look at the other ones. That PQ. So PQ has 2 tick marks. So which one has 2 tick marks? All right, so it's going to be BC or CB. Which one do they have it as a drag and drop? They have it as BC. All right, and similarly, QR is marked by 1, so that one would be AB. And then so that makes the last one by elimination. The last one is AC. Okay. So, excuse me. All right. In the diagram, you know that triangle ABC is congruent to triangle DEF. Find the values of X and Y. So what you need to do, ladies and gentlemen, is look at which one you can solve first. All right. So angle C, though, this is this one right here. Okay. So angle C corresponds to which angle in the other triangle? It corresponds to angle F. All right. Now we can't do anything with that one if you look, because we have an X and a Y. But we know that side DE, all right, corresponds to side AB. Oops. Where's it? Sorry. Tell you, they put that in the wrong place for me. So we know that DE is the same as AB. So we know that 4x minus 6 is the same as 10 inches. So that one only has one variable in it, so we're going to solve that one. So we're going to say that 4x minus 10 is 4x minus 6, excuse me, and I don't want to restart it all, so I apologize. 4x minus 6 is equal to 10. Again, I'm going to add that 6 to the other side of the equal sign, so it becomes positive. So 10 plus 6 is 16, and now I'm going to divide by 4, and x is equal to 4. So we know that our x is equal to 4. And now we can do our inside our angles, all right? So now I can say that 14x plus y is equal to 60 degrees. But you just told me that x is equal to 4. We know that 14 times 4 is 56. And on this one here, if I'm going to get y by itself, I'm going to have to subtract 56. And 60 minus 56 is also 4. So on this one here, they both just happen to be 4. That's not always going to be the case, ladies and gentlemen. It just happened to work for that one. All right, so on this next one here, it says find the measure of angle C. All right, so we need to kind of see what they have here. So we know that this angle here that is marked with one arc is 63. So that means that we can say that this angle here that is marked with 1 is also 63. The one that is marked with 2 is 75, so we know that we can say that this angle here is equal to 75 also. So we know that on this triangle here, we can state that the measure of angle C plus the measure of 63 degrees, well, 63 degrees plus 75 is equal to 180. All right, we can say that the measure of angle C plus 138 is equal to 180. And again, to get the measure of angle C by itself, we're going to subtract the 138, and that will give us 42. So our answer is 42. They already had the degree symbol there. Make sure you don't put another one there. It'll mark it wrong. Okay, and number 6, it says in triangle ABC, segment AB is congruent to segment CB. Which angles are congruent? So remember, what kind of triangle is this? This is an isosceles triangle. And with an isosceles triangle, we know that the base angles are equal. And since we know that they are equal, ladies and gentlemen, remember, I can always go from the side and go to the angle opposite. That's going to be important to us here later on. And on this one here too. So I can do that one there. So we can say that the angle A, not the measure, they weren't asking us about the measure. We can say that angle A is congruent to angle C. I'm sure if you put the C first, it wouldn't matter. All right. But just remember stuff like that. Okay. So now we're going to use what we just talked about into this last one here. Well, not the last one, in number 7. So we know that by this angle here, we know that these 3 angles are the same. So we know it's equilateral. Since it's equilateral, we also know that it is since it's equiangular, we know that it's also equilateral. So we know that each of these sides is equal to x minus 5. All right, since we know that each of those is equal to x minus 5, and this now we're looking at this second triangle, since it has these 2 arcs here, all right, we know that on both of those, it's going to make it an isosceles triangle. Since it's an isosceles triangle and those are my base angles, remember what we just learned from the previous thing there is that we can then say that these 2 sides are the same. So in this one here, we can say that x minus 5 is equal to 15. And I'm going to add 15 to both sides, and I'll get that x is equal to 20. All right. So by the same token, since we know it's equiangular, we know that all of the angles of this triangle here are equilateral, equiangular triangle. Each one of those is 60. So if that one is 60, then we know that this angle here, because it forms a linear pair, has to be 120 degrees. So if that one is 120 degrees, we know that since this one here is 3y, we know that this one here also has to be 3y. So we can say then that the sum of the angles of a triangle is always 180 degrees. So we can say that 3y plus 120 is equal to 180. We can say that 6y, combining like terms, plus 120 is equal to 180. I'm going to subtract that 120. So I'll get that 6y is equal to 60. Then I'm going to divide by 6, and I'll get that y is equal to 10. All right. And now finally on the last one here, what can you conclude from the diagram? And what theorem supports your conclusion? So on this here, it's going to be a drag and drop here, ladies and gentlemen. But remember what we've talked about here. When we were talking about congruent triangles, I told you we only needed 3 pieces. All right. So if we look here, we have these 2 angles that are the same, and sides, and we have these 2 that are the same. All right. So we know also that this angle here and this angle here, I don't have to name them right now, but we know that they are congruent because they are vertical angles. All right. So now that I've used the 3 parts, I can prove that everything is the same. So then what you'd be able to tell me here is that this distance here and this distance here is the same. So if that is the case, then we can state that that the lakes are the same length. And then we can say the theorem that states this, I believe, again, you're going to choose from it, and you should be able to say it's the side angle side. And I think they said congruence theorem. Okay. Remember, we said we're not proving them, but you can still use them. So what we just learned is that we can use this and say that these two sides are also the same length. Okay, so hopefully that'll help you, ladies and gentlemen, and they'll help you with your quiz tomorrow. Good luck.